Good morning, everyone. Thanks for joining us. My name is Mark Proud. I run the sales team here at RG Group. RG is about a 60-year-old business located in York, Pennsylvania, with facilities throughout the Mid-Atlantic. The history of the business really is in fluid power, and the industrial automation division started about 10 years ago and has quickly become the fastest growing division within RG Group. So, there are really four key technologies that are driving our business today. Industrial robots, collaborative robots, mobile robots, autonomous mobile robots that are moving material around within your facility, but probably none have a bigger impact on implementing automated systems at this point than advanced vision systems. And that's really what we're here to talk today about, how advances in vision systems are really enabling companies to do things that in the past few years have been impossible or very difficult to implement. And so, as my entire professional career has been industrial automation, we've done vision systems, traditional vision systems deployments, dozens and dozens every year for close to the last 2 decades. What we're going to introduce you to today is really a paradigm shift in how the technology is transforming ways that manufacturers, warehouse, and logistics operations are using advanced vision systems to do more. So we're really excited about this technology. Really, since collaborative robots really became popularized in the mid 2014, 2015, the advancements in vision system technology is really the next wave of what's going to unlock and enable applications at many customers. So some of you might be in different different places in your journey to adopting automation. Some of you might have 100 robots in your facility, and some of you might be looking to do this for the very first time. So I think what Don and I hope to do today is to have a conversation around what we're seeing in the field, how things are changing in the market, and how this may or may not be a good fit for you and your facility. So with that, I'll turn it to Don to give a little background on Apera.
Yeah, absolutely. I love the way Mark kicked this thing off, because there's a couple things that really trigger with me. One is, first of all and foremost, after seeing the introduction slide, I need to change my profile picture on LinkedIn, because that's actually what you saw there. Get that updated. And then secondly,
that wasn't taken last week, Don?
No.
Oh.
And then secondly, it really is having this conversation. I've been in the automation market for about 27 years. I've worked for some large automation manufacturers that are out there that provide full facility automation type platforms. And a big piece of that, and was seemed to be my career, was always seemed to be missing. There was always that little piece at the end that just wasn't accomplishing some of the tasks that the customers were requesting. And when I really came to understand Apera, and really understanding Apera AI and the solution set that they have, it really got me excited, because it is, like Mark mentioned, it really is a paradigm shift on the way in which we actually look at and integrate vision technology specifically for automation and robotic guidance. And it's really in the inception of the company itself. So back in 2016, our co-founder was actually under contract by a large global tiered supplier. And part of that contract was for him to take a different approach towards some challenges that they were facing throughout their manufacturing facility. And it was an organization that had a lot of different parts that were being either stamped, molded, casted, specifically for the auto industry. And yet they were trying to actually utilize the commercially available vision solutions that were on the market to actually accomplish some of the deep challenges that they were receiving. And it just wasn't hitting the mark. They weren't seeing the return on the investments that they had. In fact, in some cases, actually deploying some of that commercially available technology was actually providing more of an hindrance than what they expected. So some of the challenges that they were faced with. So our took this approach, took on the challenge itself, and rethought about the way vision technology is developed and how it's integrated. And this is where Apera AI came to the marketplace. And it is truly a different approach. So, think about what we tried to achieve and how Armin thought of this was we need to be able to provide human-like vision in the manufacturing facility to actually accomplish these tasks. So at Apera AI, he did that. So you look at us, we look at humans, and we say, okay, how do we actually see the world around us? More particularly, how do we see that work envelope of that field of view in which we're trying to accomplish the task? And we utilized, he started to deploy 2D technology, just like humans do, just like we do in our neural network in our brain, right? We see a coffee mug, we automatically classify that as a coffee mug. We utilize that 2D information. We look at the surfaces, the edges, the texture, and then we right away through our neural network, we define that as a coffee cup, and we can use our dexterity to actually go grab it. So in that case, since we have two eyes, we use two 2D cameras. We really focus on the characteristics of the 2D information, but utilizing the two 2D cameras also then gives us that depth of view information, right? It also allows us back in our computer system to be able to see that in a third dimension. Now, Armin's result, as he presented it to this tier 1 supplier, is a new term called 4D. Okay, so what is 4D? 4D basically is utilizing this 2D information, translating it into a 3D, and then utilizing and deploying AI, artificial intelligence. The AI piece really is the game changer. That's actually what empowers, the technology. It presents and accomplishes and removes the challenges that you would normally see in the structured lighting solutions that are out in the market, and then people are actually trying to deploy in systems. So as we go through this, we're going to talk about 4D, we're going to talk about AI, and we're going to talk about you as the customer. When you actually go through and you identify those challenges, what are those functions that you go through in order to actually design, develop, fabricate, and then put into operation that vision solution or that automation solution to accomplish your challenges. So that's what we're going to talk about today. And please, questions, roll those questions up. Let's have a dialogue.
Thanks, Don. So really what I'd like to talk about is some traditional design challenges or challenges that customers face early on when deciding to tackle an automation project. So, the business today is very different than it was, 5, 6, 7 years ago. Then there was a lot of education and time spent by companies like RG to discuss why a manufacturer might want to automate and what the advantages of that would be. And while we still do some of that, and we're doing education today in terms of how the technology is evolving, what we're seeing in the field is that the vast majority of companies have an automation strategy in place, and where they are in that process varies from company to company. But we've seen a significant acceleration of that in the last few years, especially coming out of the pandemic. So, however, I think one of the things that as a solutions provider we kind of take pride in is understanding not only the application and the customer's challenges, but really whether or not it's a good fit for automation. So just because the technology's come a long way, and just because the adoption of robotics is rampant right now, that doesn't mean that everything is a great fit for a robot or for automation. So we got really good over the last few years at saying no and qualifying applications. And what we've seen recently is, because of advancements in machine vision systems, our doors are open to more applications and opportunities than there were just a few years ago. So, but these are really some of the challenges that we see and we discuss early on in the process with many of our customers, in terms of when tackling a project. How do you gauge what success looks like? What are your performance goals? How are you going to justify that investment? What return is the company looking for, and is that something that's realistic based on the scope of work? floor space and really just how automation changes the way that and impacts the facility is a concern. It's often not as simple as just plunking down a robot where a person once stood. There's other implications and things that need to be addressed with that, especially if you're talking about larger robots and caging and things like that. So, and lastly, most companies today have existing technology platforms that they use. How can you leverage technologies that are already in place, and how can you put a plan in place to adopt new ones? So before we head into kind of a first poll question here, wanted to really just set the stage in terms of these are the kinds of conversations, these are the kinds of things that are very traditional that come up whenever we're having our initial conversation or two with a customer about a potential automation project.
Yeah, well said, Mark. I agree with you.
So
yeah, go ahead, George.
As Mark stated, this little poll question here, if anybody has any input that you'd like to put in the chat, please go ahead.
And these are key things, right? So that's the reason we have these poll questions up. Also, it helps guide us as well. So, we definitely encourage you guys to put some information in the chat on this. These are a lot of the conversations that we actually have when we're originally approached about some challenges that are happening in your organization, specifically around the operations. And we're going to hit some of those things as well, but it's always good to, get the voice of the attendees and find out what some of your most challenging areas in your facilities.
Yeah, I think what's interesting is I've seen this really depending on parts of the country, depending on the industry. If you're in an expanding industry or one that's a little bit more stagnant, it's really interesting to kind of see what's driving a lot of the decisions to automate from customer to customer.
Right now, gentlemen, we have in the chat two of the primary things that people are responding to are saving money and labor. So we know those are driving factors, and that looks like what we've hit so far. And overcoming labor shortages. So
absolutely, it's crazy. I mean, it's like I said, I've been an automation consultant for a long time, and when I travel around, especially in these large manufacturing facilities, one thing I'm seeing is very common. I'll walk into a facility, they might have a line of 7, 10 machines. In an operation, they've got bins full of parts waiting to be introduced into the process, and they have 2 people running 2 machines. The rest of the equipment is sitting idle. All those parts that need to, work in process parts that are just sitting there stagnant, waiting for somebody to be able to operate those. So there is this is a real issue. This is coming out of COVID. These large manufacturers that in the past had actually triggered that, hey, we need more throughput, so let's go hire more people. And that was really the answer at that time to the challenges they were facing. And now it's just not the case. I go through, I don't care where it is, from automotive to consumer goods. One of the key areas is that shortage of labor. They're not able to hire. And I hear stories from plant managers time and time again, the ability to actually hire people that show up every single day has diminished. And then keeping their employees long term seems to be more and more of a struggle that's out in the market today.
Yeah, no doubt. Also, I guess no surprise to see that money's at the top of that list, though. So I think as much as labor certainly is an issue. We do spend, especially, and we'll talk a little bit more about scoping, but at the end of the day, especially with larger companies, getting to that target ROI is still a critical piece of the puzzle.
We've got one addition that came through, gentlemen. So, we know money, labor, and another comment was adding additional ways to solve product design and manufacturing problems. So
yes, and that's great segue into this particular slide. So we were talking about this, and Mark and myself, and we're getting together and really talking about, hey, what's some of the approaches that we see? Can we break it down to a little framework or process that customers actually go through, engineers and technicians kind of go through when we're faced with these challenges? So what you're seeing here is just a basic process or framework of how you go through that thing. So you walk up, you've got this challenge, you've got a yield issue, you've got problems maybe with labor, something like that, or quality. And so you define this. That's really the scope. You're developing, hey, what is the challenge that we're faced with? You actually write that thing out. So some people would call that sort of a statement of work, or at least identifying that challenge itself. From there, hopefully, after you get through that, you go into a design phase. Okay, what conceptually could this solution really look like to be able to handle my challenges? Looks great. You check the box here, you go into fabrication, you start building, right? So now you put the money towards it, you put the labor, you start building that solution. Then hopefully at the end, you've come up with that solution set that, accomplishes your task, gives you your return on the investment, and you put it into operation. That's through the integration and commissioning phase. The key thing I want to focus on here is that design side of it. So from the onset, when you actually take that step into what is this system going to look like as you go through this this particular process. One thing that's advanced into the market today is actually being able to create and give the tools to these engineers or technicians, where now we can actually fully simulate in the digital world what that end solution is going to look like, even before purchasing any of the hardware or software that's around. So as we talk through this, and you're going to see some of the slides that come up, we're going to show you how Apera AI and RG Group can actually allow you to do full digital simulation of that solution, give you that confidence that what you're actually going to go through and actually integrate is going to actually meet that return on investment or defeat that challenge that you have in that market.
Yeah, so the definition of the scope of the project, in my opinion, really is the most important step in this process, because if you take shortcuts and don't really define the problem well up front, it's only going to lead to issues further down the road. So we spend a lot of time with customers up front, helping to develop that statement of work or that scope, and really make sure there's pretty clearly defined project goals. This is something that I think we see. We've got a mix of end users and integrators on the call today. So, I think end user integrators are often on the receiving end of these, and what is received and what's developed by end users, really varies from company to company. So traditionally, larger end users have processes and procedures in place to develop a fairly good scope of work document. Smaller companies, we find, often don't take the same type of rigor, and they just say, hey, you see what that person's doing over there, we want to automate that. And so while that's a terrific start, it really spending and taking a thoughtful approach to designing a scope of work document really is helpful. And I think the other thing that's important to note is, Don and I walk through a lot of facilities, and we're not, true consultants in the sense that we get paid for our time to tell people what they should do or how to do it, but rather in the implementation aspect of it. But we have a lot of interaction with customers where we're walking around facilities where they'd say, hey, we'd love to automate this, or this is a bottleneck of our process, and often I think they look at us and say, what do you think we should do, or how should do you think we should automate this one or this one? And it's a really difficult position for us to be in, because we don't know your facility inside and out like you do, right? Where your bottlenecks are. That every 17 days something happens where you need to some variable pops up that might make it difficult to automate. So that we really lean on the end users, and it could be an iterative process to really develop a healthy scope of work document. So these are just some of the aspects of that are typically in it. Again, what's going to drive that investment? We talked about money earlier. Whether your ROI target is 3 years, 18 months, or 3 days, trying to get define a problem and understand if it could be solved at the price point that drives that ROI is important. I think what's interesting that we've seen is, while labor savings or labor reallocation is a driving force behind ROI, there's an increased amount of other aspects that are really creating really good return for customers. And it might be safety, it
Yes.
might be product quality, and I'd say more than anything, it is becoming flexibility and agility. So how flexible can this cell be? There's very few. We used to call them, monuments within a facility, right? You bought $1 million machine to do one specific thing, and then, that job ended, that program ended, that contract ended, and now you've got $1 million piece of equipment that does nothing else for you. That's just not how companies approach automation anymore.
I like that.
Yeah, go for it.
No, I like that. I absolutely hit it. So just add on to everything Mark's saying. So when we actually look at scope, and one of the great things to be able to do is, you define that challenge. You really see some of the things that Mark had mentioned. And I love taking that next step and really getting down and start talking with the people that are actually, facilitating that operation. What is that machine tender seeing? What is that the labor that's actually experiencing those nuances, right? And it can be that simple. Some things can be lost in translation because you really look at those high points. This is what I'm trying to accomplish. And as the consultant, really from the scope and defining that, you've got to hit those little nuances, because those little buried things could really be the nugget, the golden nugget that actually really hits that ROI. And that's something that if we highlight as one of the chief drivers towards that automation, all of a sudden your gains are much higher than what you expected. So I love going in there, seeing these, defining that scope, and then also standing there during the machine operation and experiencing that as well, and try and get the insight from the people that are actually engaging in that operation. And
I think
those little things get added into it. So
often you look at a task from a distance and it looks simple, and when you really dive into it, you realize there's a lot of nuance to that task that needs to be taken into consideration in order to make the automation successful.
Absolutely. So let's take a look. Let's take that step into from a perspective of from the automation side. Let's look at the design side of it. So first and foremost, we go when you start talking about your application, you're thinking about automation and robotics. One of the key factors you have to determine is it a cobot? Is it something you actually want to put in the operation unguarded with some safety integration that's already built into the design of the robot itself? And those are the cobots, right? They can interact around labor. Or is it one of those applications where, hey, speed is of essence? So you actually need to that yield, that throughput. And so you're not going to get that from that cobot solution. They're inherently, the way they're designed, they're going to run slower. Cycle times are going to be slower. So you might have to go hard gated, hard fabrication, utilizing an industrial robot, where you've got to put the guarding and fencing and things like that around it, but it's going to give you that speed. It's going to give you, in some cases, even some more accuracy as far as repeatability when it comes to an industrial robot. But that's from the onset. That's one of the first decisions you have to make. And a lot of those have to do with, hey, is it a greenfield or is it a brownfield? Am I looking to integrate into an existing facility where I don't have that floor space in order to put an industrial robot in, because you're going to need more space to put all that guarding around? Or is it, hey, I want to slide this little robot inside there, put it, make sure it's a cobot, it's safe, and this way, I can actually insert it into my existing facility, and I don't have all that extra expense with all our guarding and things like that around it. So then we're looking at what we got highlighted here is really looking at obviously first step was looking at that cell design, cobot robot. And then we're looking at, how are we going to look and see the operation? How are we going to be able to identify what's going on that's important to us in that particular operation, so that we can then contextualize that information and utilize it just like humans would do. So what you're seeing up there is the vision system from Apera AI. And what we're showing there, this is a large, we're going to get into this case study a little bit here on a few slides. What we're looking at here, this is a large field of view. So the product is fairly large. And here at Apera, when we talked about utilizing two 2D cameras, it's fully scalable. So in this case here, the part was so large that we actually deployed 3 pairs of cameras, all communicating to one vision computer. And then from there, we're actually providing the robot guidance in order to handle the operation. So when you're looking at these things and looking at design, you want something that is scalable. And at Apera AI, we're definitely scalable. Now, we talked earlier about, utilizing that simulation. So you've heard everybody's been hearing a lot about AI and what AI can actually do for the world. And our approach here with Apera is, in the core of us is the AI. We are a software organization. What you're seeing in front of you is a challenge that came to us from a customer. We utilized our AI deep learning algorithms, and we defined, hey, what does that tote look like? That's going to be presented to the camera. What are the objects? What parts do we be able to recognize quickly, and then deploy that information to the robot to actually accomplish its task, which is to empty that bin of parts into the process. So everything you're seeing in front of you is not the real products. This is actually something that's been created through millions of cycles through the teaching and the algorithms of the AI, creating synthetic models. Synthetic modeling is really the power of AI. And so on the left-hand side, you're actually seeing the tote created in the digital world. You're also seeing all the parts as they be presented to the camera system in your manufacturing operation. And through a very fast vision cycle, which is somewhere around 300 milliseconds, we're able to identify quickly everything that's in blue there. Those are all objects that I see fast. I can take an image capture, 300 milliseconds, say, everything in blue, I see you guys. The next step, you see the things that are actually boxed out in orange. That's also within that 300 milliseconds. I say, I see you too, but you're occluded. So you're underneath the ones that are in blue. And from the path planning perspective, it doesn't make sense for us to actually go and try and acquire those objects. Then that's all the 2D information. So we just use 2D to recognize those particular objects, and we define what we call candidates, ones that we can actually go out and acquire. The ones you see in the pink, it's moving around that box as this thing is running. That's the one that we decided, hey, based upon utilizing auto path generation, this is the most efficient part for us to actually go and acquire. So once we do that, then we actually deploy the 3D information. We actually see it in that third dimension. Now we also have that depth of field information, and then we can provide the full auto-generated path plan to the robot to go in and acquire that part and then come back out of that bin as well. And then on the right-hand side, we basically modeled the entire operation. Robot brand, robot model, the model of the end-of-arm tool. So how do you plan on, looking at dexterity, how do you plan on grabbing that object, right? That's part of the entire equation. And so we model that as well. And then we can run through a series of picks and validate the entire design. Was the tooling correct? Were we able to see and acquire every one of those parts and accomplish our task, which is to empty the tote? So that's the power of doing actually digital twin simulation prior to actually purchasing any of the hardware.
Yeah, and if I could add something, Don, I mean, I just want to reiterate what a powerful tool that has been for us. As a solution provider that has sold 3D vision systems for bin picking applications for 6 or 8 years. The thing that has historically prevented customers from moving forward is just the lack of the perceived risk, or the lack of just a good sense that the project was going to be successful, because in many cases you were doing something that had never been done before. And so by being able to simulate that in a pre-sales environment at no cost to the customer really removes a significant amount of risk for the project, both from the end user, but also from the integrator as well. So it really provides a level of assuredness that really has not been available with other technology platforms.
Yeah, I agree, and that's now I would say that based on the hundreds of applications that we've been through here at Apera, one nice thing about it is that we walk through a facility and see what the challenges or what the customer is requesting. We do have, from our engineering perspective, a high level of confidence in a lot of these applications that these things can be accomplished. We're really seeing a lot of that digital simulation come around is, questionable objects, objects that, as a human, and this is one of the key takeaways, if a human can function in that environment successfully, at Apera, our vision solution will work as effective as that human. So if it's something we walk up to and it's easy to translate exactly what needs to happen in order to accomplish that task, utilizing your neural network in your eyes, we know that our vision system will be able to do that. I've had several applications where that's not the case, where we actually challenged our engineers. We've had some translucent diaphragm material that actually went in medical pumps, and they came in a bulk, and they're on this torque separator where they're trying to separate these objects. And we had our engineers one at a time walk into our lab and say, tell me which one is on top. And in that case, every one of them failed. Nobody could tell which one was on top. And so what we ended up doing is we had to step up our algorithms and go through a little bit more training of those objects. And after we trained those objects a little bit more, to find a little bit more of the resolution in the algorithm itself, through the deep learning algorithms, we were able then to accomplish the task for the customer and define which one of those objects is actually on top on that bulk. So it really is amazing. This is a paradigm shift. This is changing the thought process towards how you actually look at automation when it comes to applying vision for your applications. Another key feature of us and what we did, we've kind of talked about vision. We talked about vision applications. Speed is a key thing, right? We talked about these applications. You've got to get the yield and the throughput. This is great. I'm glad Apera is here. You can see just like humans, you recognize their object, but you know what? I need the yield. This has to happen quickly. So when you look at speed of the vision cycle, and I'm going to be able to define that clearly for everyone. When I talk about a vision cycle, what that means, and I say 300 milliseconds, within that 300 milliseconds, we're taking that image capture, just like we saw on that tote, seeing all the blue, all the oranges, defining the pink one, the one we're going to pick, translate that information back to the vision computer solution, and then auto-generate that path plan. So when we say 300 milliseconds, we're doing all of that within that 300 milliseconds. So really, the bottleneck in a lot of cases really comes down to the robot. It's no longer the vision solution that you're actually deploying. In this particular case, and why I love this particular demo, which was actually on display at Automate, is we've got 3 vision regions that are going on here. On either side, left and right, you're seeing a mixed skew of 2 different bolts. And the only thing that separates those really is the pitch of the thread. And so what we're actually doing, we're doing an image capture inside the tote. We're defining that pickable object. We're providing the path plan to acquire that object, and we're more classifying that. We see it and we go, okay, are you a fine thread or a coarse thread? And then we're coming over on the tray, and again, we're utilizing robot guidance. We're providing the path plan to actually place the bolt as well. So we're picking, classifying, and sorting, and then we're placing them on that tray. And we're doing that all within about 300 milliseconds or so within that vision cycle. This is the case study from the design slide that we talked about earlier, right? We looked at, now we're taking a different look at it. Now this is in real operation. So what happened here in this process? So in this particular customer, it's a tier 1 supplier in automotive. This is actually a plastic extruded object that actually gets snapped into a large automobile. And when they designed this system, obviously it's their production floor, it's coming off, gets indexed into this fixturing. And their first concept was actually, since we have, we designed it, we have the CAD models, we know where we need to place those clips, they actually designed the system to operate blindly, no vision whatsoever. And what really occurred in resulting of that was almost a 20% defect rate. And the reason being is, hey, it's an object that was that was injected, so there's heat involved. It is a plastic material, so you get some thermal dynamics that occur inside there. And next thing you know, those placing points are off by a millimeter or so. And based upon that, they could not actually operate this thing in a blind robotic mode. So in comes Apera. This is where we have the 3 pairs of cameras across this whole object that you're seeing. And then what we do is we take an image capture with inside the one field of view. We're also able to define all the placing points on those plastic stanchions that you see sitting up there. And then we can provide the auto path plan. Just keep feeding the new path plan to the robot so it can actually index in the new clips and then press those in on the exact location they need to be. It removed all the need for the labor to come in to correct the quality issues that they were having. And now they're running at 99.99% efficient. And it's been a true success story for us. And it's a case study. It's actually published on our website as well.
I think what's really interesting about this application, it took me a few times seeing that video to really like connect all the dots here. But I think generally when we think of 3D vision and bin picking, or you think of 3D vision, it's generally bin picking. We're picking something up from a chaotic state and then placing it into a fixture. And this is almost the inverse of that. We're picking from known locations, but the variable here is the location of where you're placing the part.
Yes.
And so it's an interesting one because it is almost 180 degrees from what people traditionally think about applications for 3D vision.
And it's true. Even on the last video, we're actually sorting the bolts, right? So when I talk about auto path generation, you think, like you said, bin picking. So what's the important part? What is that mess that's being displayed to the camera? I need to get those parts out of it. How do I define the trajectory and path plan for a robotic arm utilizing designed end of arm tool to be able to go acquire that? The inverse of that, now what do I have to do with that object? Well, that's on the placing side. On both the pick and place side, our accuracy pose estimation is in the sub-millimeters. So that's why we're able to take this particular application, which is more of the placing piece on robotic guidance, the opposite of the picking piece, and still deploy that technology in that same fashion. But now we're just placing and we're able to do it at high accuracies as well.
So moving to the next step in our four-step process is we've developed the scope, we've designed the system, and now it's ready to build it. And the decision to build it in-house or to outsource to an integrator is probably a decision that's made upstream of this, but it's worth noting here. We see a lot of savvy end users, generally larger companies that have their own internal engineering or integration automation teams that are building systems for themselves. It could be a shared approach where an integrator takes on a portion of the project and the end user takes on a portion of it. Maybe there's some process knowledge that would be difficult to share with an integrator or get them brought up to speed. We mentioned this earlier. There's no more kind of islands of automation anymore. It's rare that you'd have a standalone machine that's just cranking out 2 million of the same part, every year and never changes and doesn't have to integrate with upstream or downstream technology. So really understanding from a fabrication and integration standpoint, how are we going to get product into the cell? Where's it going downstream of the robots? Are there industry 4.0 initiatives within the company? Do we need to collect data and share that to an MES or a SCADA system? Those are all things that really are important in this fabrication phase. I think one of the things that's been an interesting kind of shift is with the proliferation of robots, that getting a robot arm to move from point A to point B has really become, in some ways, almost the easiest aspect of automation projects, right? There's you could pick any one of 22 different robot brands that's going to pick a 5-pound object from point A to place it in point B with sub-millimeter precision. I mean that's rarely the difficult aspect of building systems anymore, but it's really designing something that's flexible, that can fit in the operation, that's going to accomplish the goals for today, but also leave room for growth moving forward. One last note on here too, I guess just from a fabrication standpoint, we're seeing a lot more specialization within integrators. So if you're welding, you're painting, you're palletizing, there's a lot of companies out there that focus specifically in those types of applications. So seeking integrators with the right level of experience, not only in the industry, but for the application, but also have the experience with the technologies that ultimately you want to integrate or that you want to see built into the cell.
And one note on that, Mark, you hit a really great point because it was a buzz a few years back, and it's still very important. which is Industry 4.0, right? Or IoT, the Internet of Things. And people are really still, obviously it makes a lot of sense to deploy that. You want much intelligence and data KPIs you can actually grab from the actual operation, where the rubber meets the road. How are we doing things? And I just want to say, based on that last video, the one video we were talking about when we talked about the bolt picking, we're actually utilizing information like that. We're actually doing counts. Every time we pick a coarse thread, we're counting that. Every time we pick a fine thread, we're counting that. And why? Because we need a fully assembled tray of the right amount of those pitched threads on either side of that tray, which becomes then a completed assembled part. And so in the AI, we're seeing we're able to accomplish that task, but we're also tracking, the speed of it, the placement of it, and the count of each one of those. And that might be the information that needs to be brought back upstream to say, we completed X amount of assemblies of this tray throughout our shift. How many are we doing per hour? And that's the information you can bring back into what you're talking about. So it's great insight. So let's talk about another challenge that we see in the market that Apera 4D technologies has been able to face and actually provide solutions. There's another demo that was provided at Automate 2023. What we're showing here is the FANUC cobot solution. And what we're trying to do, we're intentionally inducing a lot of reflectivity into this cell. We're flashing a lot of multicolored lights on this thing. We're actually picking up stamped automotive parts that are also reflective in nature. And then we really stepped it up and we said, great, let's actually do all this and do the placements utilizing a very shiny reflective surface that we're actually going to stack these particular parts. So what's happening here in this operation, there's going to be a scan where we kind of go back, is we have 3 vision regions that are going on here. So we've got 3 sets of cameras. We have 2 bins in which we're actually acquiring these objects. And then we're actually stacking them without fixturing, right? Still just utilizing the auto-generated path planning based upon if it's upside or upside down. And that's what you're seeing on the 2 stacks. There's a view from the top. You see 3 pairs of cameras looking at 3 work envelopes, and we're able to take that information from all of those and provide the path plan to the robot through this operation. And what's really nice, you're going to see this coming up here in a little bit. We take an image capture, we identify, like we said, the most recognized objects, and then we highlight and focus on the one that we actually want to pick. And then from there, we go acquire it. Well, there's going to be times in your operation based upon the way the objects are actually presented where, hey, you can take an image capture and there are no pickable objects that are in there. Maybe they're all occluded, or based upon your tooling strategy and the way that the parts are orientated, there really is no way for you to acquire that based on where you actually had the taught pick points. Where do I want to acquire that part over and over and over? They could be displayed where, hey, I see it, you're occluded, and based upon my teach points, I can't pick you in that particular spot. However, you are occluded. What I can do is I can say I'm still going to do occluded picking, which means I'm still going to attempt to pick you. Whole objective there, and you're going to see it happen here, really is to stir the pot, right? It's to pick it up, drop it back in there. So this way I can take another image capture and then go acquire you correctly based upon my teach point. So this way I can finish the operation, which is orientate you properly and place you accurately on these stacks. So that's what you see happening here. It should be coming up soon. It's going to be on that left-hand side where you just kind of pick it up and just drop it. And that's a key thing, because I do get in those applications where it's a simple part. It's like, okay, it's a stamped metal part. We're always going to be able to see those like a human and be able to provide the path plan. But the end-of-arm tool strategy and the vision solution is, like Mark had mentioned, is a system. So for it to really be efficient, meet your yield goals, they have to be aligned properly for you to be effective with trying to accomplish that task. Inherently, just the way it is in dexterity, there's always going to be a point in certain cases where you're just not going to be able to accomplish the proper grip and go straight to an assembly. In some of those cases, maybe you can still grip it, but then you have to go to a flipping station, right, to re-grip it. Grip it accurately where you need to, and then go through that operation. I think this next pick here, you're going to see it drop. Nope, it's not this one either. But
the next time it goes back to that to the left one, but I'm going to speed through this a little bit because I want to make sure that we have time for our summary slide, which is next, and then and then we want to leave some time for Q&A. So you know, the final step of the 4-step process in terms of implementing a vision guided robot cell really is the operate phase. So this is where you're commissioning the system, doing some operator training, maintenance, and monitoring the performance moving forward. Defining that acceptance test. You know, how do you define success? How can you sign off on the system to say it's good is a key piece of the puzzle here. Implementing the system. How do you minimize disruption to the facility and to production when implementing it is important. If you're working through an integrator, what kind of support and maintenance plans make sense at this point? Is there any kind of preventative maintenance that is necessary to keep the system running, performing well? And then lastly, when you're monitoring that performance, are there KPIs? Are there metrics that you're monitoring and sharing throughout your organization?
Let's give a summary of this particular operation. So this is another very large tier 1 automotive supplier. We're looking at transmission casings. This was a retrofit application. So this was already deployed. They actually had some structured lighting solutions that were out there. And yet, even though their best go at deploying that vision technology, they were still having yield issues. And the highlight and the piece that I want to talk about is, number one, how large these casings are. Number two, how high up you're seeing those cameras to be able to give that field of view that's required for this robot to operate in and get the pixel resolution that's required to actually accurately be able to grab this particular casing. And by the way, where we're actually grabbing the casing is not within a line of sight of the vision. So how can you do that? Well, you can do that based upon starting off with the perfect model of that casing. It starts off with the CAD itself. So we actually learn and put that CAD information into our deep learning algorithms. Now we know every attribute of that particular object, even if it's not displayed to the cameras themselves. So as we take the image capture, we see the profile side of that casing. We know exactly where, based on that tool design, where it actually has to go and deploy to that path plan to be able to acquire that part. So there's two-step operation here. One is to be able to acquire it properly. Second thing is we have 2 pairs of cameras up there, so we're actually orientating correctly and placing it into a laser etching station where it's actually engraving the information on the casing itself. And based upon using Apera, they saw a 10% increase of efficiency on the cell itself. Key takeaways.
Yeah, just to do a quick wrap up here, I hope what Don and I have been able to share is just a little glimpse into how leveraging advanced vision systems like Apera's technology really is inverting the traditional model in the way that many customers would approach automation. So, when I think back to part presentation, how a part gets to an operator or to a seller or to a machine has long been probably the single most thing that has prevented companies from automating. And there have been solutions out there for decades, whether it's bowl feeders or more recently, we've seen a lot of flex feeding technology, and they both have their place in the market, and both of them are widely used. But ultimately, to really automate a cell the way that it's running today with the least amount of infrastructure, we're seeing just a tremendous trend towards using advanced vision systems to unlock and enable applications that historically we haven't been able to solve.
Absolutely, Mark. So another key piece of that is here at Apera, based on the inception of the organization, we're really, like it states in the first bullet point, right? We're really inverting that process, the things we just kind of talked about. In the past, utilizing automation, hard automation or software, you really start off with that hypothesis, right? You've got the scope, you define the challenge, and you're trying to put together your best foot forward to actually create that solution that's going to alleviate those challenges, give you a return on the investment. So in the past, you've gone out, you've taken a look at what you think is the best hardware that can meet your challenges, hit your budget requirements, and then you throw out a lot of man hour inside there when you look at programming and making that something sort of customized in order to be able to deploy and get the effect that you want from it. At Apera, we do invert that because we take it from the AI side. Let's start the process differently. Let's take a look at the application. Let's look at your objects. Let's talk about the challenges, whether it's reflectivity, is the part clear, is it transparent, is it highly reflective and shiny, is it a black object? What kind of environmental conditions could be impairing the structured lighting solutions that would be there? You know, light, natural light coming in from bay windows, things like that. You would need to be able to go from a lab design side and commissioning side, and it has to be seamless. And you've got to reduce the labor that's required to actually commission and get up to the yield that you want in production. So inverting that, taking that process back, looking back at the real model, the CAD, the perfect image of that, creating synthetic models of that, other instances of that, and how it actually could be seen by the camera, you've now are deploying what we call a robot-ready program. All that information is put together for you to include the robot brand, so we understand the communications, the call routines, everything from that robot, and we're deploying that into the image computer. And then from there, all you have to really worry about is the other parts of the process. Take away the need for that vision expert to be on site. We're also reducing, completely eliminating the risk associated with, did I buy the right combination of hardware and software to actually accomplish everything I want, up to getting that yield that we need from the equipment. So we do take a different approach, and I really look forward to talking with everybody about your applications and talking more about these steps and how we can work with you to accomplish your challenges.
So before we wrap up, one final poll question again. Feel free to add in your thoughts on this in the chat, and if you want to follow up with any specific questions directed to Dawn or I, please feel free.
Yeah, so if everybody puts their comments in the chat, I'll read them out in order to the team so we could take advantage of our time and then hit everybody's comments and concerns accordingly. All right. Future scalability from John, gentlemen.
Yeah, I can address some of that as well. From the vision side, when you look at scalability, where the Apera solution is designed inherently, and you saw that in some of the demonstrations, right, from real world integration to some of those demos, is you can start off with a Apera vision computer system and one pair of cameras. So you've got an operation that you're functioning in. It's one robot, one field of view trying to accomplish a task. It's completely scalable. So let's just say now this operation is a little bit more complex, or you're actually trying to attend two different lines. You can actually scale the camera systems up to 4 pairs of cameras to one computer system. So now you can have that robot actually operating in 4 different field of views in work cell environments, and then accomplishing that task. If the cycle time permits, you know, if you have something where the robot cycle allows for it, you can actually also, from that one Apera computer, is actually serve up to multiple robots. I do have applications where I'm actually serving to 3 robots from one Apera vision computer. So I've got 3 robots actually operating out there based on their sequence of operation, right? It looks seamless to them all. The robot's still not waiting on us. We actually take the calls sequentially from the robots. They actually do get put into what we call a buffer area, and then we service those in a sequence operation. And based upon that full robot, whatever it's doing, by the time it actually really needs its path plan, we're already ready there, and we serve it up to them. So expand the cameras, and you can also expand to multiple robots. Then let's just say you've made your investment, and you thought, hey, this is product X. I need to be able to acquire this and do something in the process. 3 years later on, or even less, you decide, hey, I've got this is not a high runner anymore. I need to really focus on this part of my operation. You can redeploy that investment, that asset that you actually acquired. Maybe you need to move to another line. Maybe it's just a new part that you need to be able to do something with that same production line. We can train that object, deploy it to the camera solution that's on site, and now you're picking that new object.
Yeah, that was the topic that I was going to hit on, Don, is we've seen a lot of companies, buy $30,000, $40,000, $50,000 bowl feeders that are really, they're fantastic part feeding mechanisms for a single SKU or a single part geometry. And in my experience, the only constant in manufacturing is change, right? So, the something's going to change: the facility, the layout, the part in some way, shape, or form, and then all of a sudden that investment, is really useless. Whereas with this, train a new model, install it, and you're up and running. So it really really unlocks a whole another layer of flexibility and agility that traditional kind of more fixed automation doesn't provide.
Oh, absolutely. You're breaking the chain of hard automation. Hard automation was great, but it does not give you the scalability and flexibility that's required in today's environment.
Okay, gentlemen, we've got a few more that are rolling in regarding concerns and some additional questions. So I'm going to hit them as they've come in. So one concern by Amanda is that the in-house expertise we've got there and the ability to maintain equipment.
Well, when you look at it from the Apera perspective, we removed, like I mentioned, that need for true vision expertise in-house. Look at this really as buying a camera solution that you're gonna deploy. The system, after being fully designed and taught specifically for your objects and your environment, is maintenance free. So from the vision solution side of it, when it's up and running, there really is no maintenance whatsoever. The only thing that I would say might have to address is if somebody with a forklift hits the side of the equipment and all of a sudden you knock the cameras out of alignment or something like that, which there's a lot of flexibility with that. So it's got to be a pretty good jolt actually to move the cameras. And then from there, it really is nothing more than like a 45-minute recalibration of the camera solution. So yeah, based upon getting a robot-ready program, it removes all that you consider a skilled labor requirement in order to have this up and running.
Yeah, it's no longer are you writing 1,000 lines of code to deploy a vision system. It's a completely different approach.
So to follow up on that, the next concern was one of the trepidations that you've got listed there, that it won't work as planned. So Samuel, hit on that one. Will it work as planned?
Yeah, and that's the elimination of risk, right? That's taking the different approach, inverting that process. Really taking a look at what we are trying to achieve. What does that object look like? These are all the things we're going to do up front through what we call a real application review. We're going to actually assign a robotic solutions engineer from Apera to actually walk, RG group, your integrator, you as the end user through this whole integration process, right? And providing that high level of confidence that it's going to work and you actually deploy it. And the part Samuel's hitting on is something I see repeatedly, and that is utilizing some of the commercially available technology. Once you deploy it in your operation, then all of a sudden you realize, hey, I have a skylight ahead above it. It's casting shadows now as the robot moves. That impacts my ability to be able to see it. My yield and my uptime in my machine is reduced. I'm not getting what I want. I truly had an application where they deployed a system, and every time it was right by big bay windows, every time a forklift would ride by and create that shadow across that work envelope, everything stopped. And they had to actually, really focus in on identifying, controlling the ambient lighting that's in that work cell. Through the deep learning algorithms, we're immune to the variability of ambient lighting conditions. I don't care if it's a dark area in your facility, or if you say, hey, it's right by these bay windows. You can go from lab design and fabrication to true FAT in your operation, and it's going to function. You can even put it outside. I've got applications where I'm actually outside functioning in the AI world.
Okay, great. So I'm going to read a couple more. Again, if anybody has specific application questions that they'd like to dialogue or have a conversation with Mark and Don about in greater context than this, at the end of the presentation, we will be showing their contact information. So if you wanted to reach out as well, set up a Microsoft Teams virtual call with them or contact them via email, that'd be great. I'm going to continue to read these gentlemen. So the next one comes in from Logan. Does the system provide any part qualification capability, i.e. defect, dimensions, etc., or would a more traditional vision system have to be implemented along with the Apera solution?
That's based on case. So what we can do is we show that we're picking those parts. Let's say a kitting situation, a part present type, to ensure maybe that assembly is complete. We can actually obviously train all the objects. We can also train that placing point. Let's say if it's a blow mold where we're putting sockets and stuff in, like we had on the introductory slide. That blow mold becomes an object. We train that. We know all the attributes about that object. So from there, we can actually acquire all the right sockets in that particular case and ensure the finished product is correct. What I mean by that is, do we have all the sockets? That's one. Two, are all the sockets actually seated correctly, or are they on angles? We know what that perfect image of that finished assembly should look like. So with that, we model that, and then we look for that. So we can take another image capture of the finished assembly and say, yes, it's all done correctly, or it's missing something. By the way, it's missing the 3/8 socket. I know that was in my one vision region. I know that's in bin 3, and I can go pick that 3/8 socket and make sure that's assembled. Now, I do want to challenge you guys on this and start looking at this from the inspection side. Since we do start off with the perfect model, that CAD, we know what a good object should look like. And so as we move into the inspection side of things, I do want you guys to challenge us on that. We are actually working towards creating, say, a guideline within that function that we can actually do real quality inspect of those objects. Just like doing what we talked about through synthetic modeling to create what that object should, needs to look like. You can invert that as well, as we keep talking inverting the process. Now you can create that synthetic modeling of what a bad object looks like. So if we can define those imperfections that we need to really look for in those objects, we can actually start training those and seeing that and then classifying it as a good object or bad object. And we want your input. We want to get challenged on those.
All right, great. Thanks, Don. So Samuel has a follow-up question from his earlier one. How many images do you typically need for training? What does that process look like? What happens when a part changes? Does that start from scratch? Does that require a program that only your team can provide?
Yeah, at Apera, what we do is we do start off with the perfect image, the CAD model. We do have an online portal, and in that online portal, there are some questions that are in there. One is we want the CAD models of that particular object. If it's a complex part, so in other words, maybe through that process, it's maybe it's a milling, cutting, something like that, where there could be some occlusions that end up on that object, say some oil, things like that happens in your operation. We want the CAD model of the perfect part, and then if you can, take some pictures of the object itself. What does it look like during that process? How is it going to be displayed to the camera? All that information gets put into the deep learning algorithms of the AI and allows us to create those instances of the object, how it's going to be displayed to the camera, so we can intelligently say, yes, that's the coffee mug. Here's the handle. And we can always find it. We can always do something with it. So it is something that needs to be done and taught with inside our supercomputer solutions, through our AI deep learning algorithms. But that is the reason why you have a robot-ready program that once it's deployed, you can move away from being that vision expert straight into that next step, which is really focusing on the rest of the automation that's there. So taking that direction, inverting that process, gives you a product that eliminates the risk and something you could deploy, quickly and get up to operations and fast and see your return on the investment. If you do have other objects that need to be trained, yes, you still go into the portal. It gets submitted to us, and then we train the object. Timeline on that is somewhere from 2 to 3 days to a week to actually train that object.
All right, great. Thanks, Don. We've got one final question here from Eric. Since the system is AI-based, can it continue to learn about the application while it is in production?
We do have a level of machine learning that occurs. We try and consider a lot of that up front. If there are situations where there's a little bit dynamic and maybe we haven't thought of all that information within the HMI unit and the software itself, you can actually record those sessions. So if you're actually out there and it's picking, all of a sudden you're starting to see maybe it's delayed. The image capture is something that maybe the solution hasn't considered, through its computations. You can record all those things. We can quickly get online and actually adjust based upon machine learning information that's maybe something that hasn't been thought of in the past. So it's a really quick support call that we actually can make those adjustments.
Okay, great. Thanks, Don. Thanks, Mark. That's all the questions that we have that have come in to date so far. This is the contact information for Mark and Don. You can reach out to them via phone, via email, request a setup for a virtual meeting. We also send out a follow-up email in the next couple of days with their information, as well as a link to the webinar as well. So thank you, everybody, for attending today. We hope this was beneficial and you've got the information and knowledge you expected and needed to move forward with your projects, and appreciate you joining the RG Group and Apera AI Systems.
Thank you.
Thank you all. Thanks, Don.
Thank you, Mark.
Thank you, gentlemen.